to do this a little bit differently today. We are going to go over Chapter 4, but rather than just me lecturing, as I already mentioned, when you first came in here, start up the virtual desktop, or get into it, go to the P drive for the class, copy the folder with today's date on it over to your virtual desktop, start up Visual Studio, and then bring up, there are two projects in there, both in folders. Bring up the project that's called Employee Copy 2 in Visual Studio. I'll give you a couple minutes to do that. We'll get done with Chapter 4 today. Next week will be lab for the entire week for you to work on the two assigned programs. The one that we did in class the other day, which was the enhanced BMI, and the other one, which is the distance converter, and we'll talk again about both of them by the end of class today. So I'm going to be going over the material that's in Chapter 4, but I'd like to make the amount of time that I spend literally going through the stuff that's in the book to be as minimal as possible. I'd rather show you via code the stuff that's going on in here. So that's pretty much what we're going to be doing. Hopefully no one had any problems doing this. You're all able to do this by now. Again, start up your virtual desktop, go to the P drive for the class. You've done it enough times. There should be a folder in there with today's date on it. Copy that over to the virtual desktop. Just plop it out there. And once you do that, there's two files in here. Chapter 4 Demo and Employee Copy 2. All right, I want you to literally double click on the Employee Copy 2, and then right here on what's your Visual Studio solution file, this one, not the folder but the other one, just double click on it to bring it up. This should look very familiar to you if you look on here. The difference is I have exception handling without writing a try-catch statement. Bless you. And that's one of the first things that's discussed in this chapter. All right? So what I want to show you is, first I want to run the program just so you can see it. It basically operates, runs the way it did before. So if I put nothing there, input must be between 1 and 84. If I put non-numeric, it says non-numeric input must be between 1 and 84. If I put something less than 1, out of range input, or greater than 84, out of range input. If I put a valid value in here, now I go through the same thing with the other one. So again, if it's non-numeric, it says non-numeric. If it's out of range, it says out of range, both on the negative end and on the positive end. And if I do put in something in here that's valid, everything appears. So basically it runs the exact same way as the program that we went through the other day. What's different is the code to make it do this. There are no try-catch statements in here. All right? One thing I did before I started today is I literally went out and went online and took a look and found a few different things, but this was one of them, out on stackoverflow.com. If you've never been out on this site before, literally if you've never been out to stackoverflow.com, it's a great site for basically anything IT. You can register out there and then you can post questions. What they don't want is for people to post questions that say, hi, my name is so-and-so, I've got an assignment that's due Monday in my C# class and I don't know how to start, so if I give you the specs, can someone write it for me? That's not the kind of site it is. But if you run into what seems to be a very weird error or whatever, the chances are pretty good you're not the only person who's ever run into that error. All right? So literally when I Googled why not use exception handling, this example from Stack Overflow, the one that I'm going to show you now, is one of the ones that came up. All right? So it's why not use exceptions as regular flow control. And the author here gives you a couple reasons. I'm not going to read this to you. But basically what happens when you use try-catch statements, or too many of them, is you are doing object-oriented, all right, programming. And when you do this, and when you catch an exception, it's making a new exception object. It has to do a lot of things behind the scenes, and what ends up happening is your program runs slower. All right. So the idea is the only time you really should use try-catch statements are either A, if you have no other choice, all right, or B, if it really is an error that's so severe that if it comes up, the program should terminate. But, I mean, think about this. In the example I just showed you here, all right, in this one, should you terminate the program if the person puts in something non-numeric? I don't think so. So really, there's no reason in this program right here to use try-catch. It's okay to do it, and I showed you how to do it. But now let's talk about the other way that it can be done. So I want to go over the code. And again, you've got all this. If you copied over everything like I asked you to do at the beginning of the period, you've got all this. All right? So I did add a comment up here, another attempt. All right? This one with try-catch, etc. And so this is what it's been replaced with. All right? And what we're saying here is couple things. First of all, notice I changed the type from double to decimal. All right, did I have to do that? The answer is no. All right, but changing it from double to decimal basically says that you're working with something that you're going to be using for monetary reasons, which is what this program is. And the decimal type, as opposed to the double type, has been optimized to work with currency. It'll still work fine. I mean, is it really going to matter when you're doing this program, for example, if when you compile and run it, if it takes 0.08 of a second as opposed to 0.05 of a second? Probably not. However, if you're working in an atmosphere that's real-time sensitive, and there are those kind of things all the time. Think about this. If you've never done this before, if you've ever gone out to a site that sells tickets online, a lot of times when you go out to that site, they'll show you a window with all the tickets, and you have 45 seconds up to maybe a minute and a half because they've frozen that screen because they don't know where you're going to buy the tickets. But then you give it up. So that's something that's real-time sensitive. If you're working for NASA, all right, as an example, being off by 1/1000 of a second could be the difference between hitting the moon and missing it. All right? But we're not doing anything with that amount of sophistication. So although I did make these decimal and I changed all these, we didn't have to. Notice when you use decimal, if I just put 1.5, it doesn't like that because it says, no, that's a double, and you said it was a decimal. You can't put a D there because that's another one that you use for double. So for some reason, they decided to use M for decimal. Notice when I set these things to 0, it didn't give me error messages, but I think I can say 0M here, and either way it would work. But if I am going to put an actual value in there like that, it wanted it. And that, the decimal constant. So why didn't it want it here, or here, or here, or here? Because those are all whole numbers. That's probably why I didn't need it here either. But since this does have a decimal component to it, just putting in 1.5 or putting in 1.5D with type decimal would not work. All right? Now, when we did the try-catch, okay, we attempted to go in and do some work, some conversion work, and we're doing a similar type of thing here. But now instead of, bless you, double.tryparse or int.tryparse, we're using decimal.tryparse because what we're trying to parse is a decimal. We're trying to grab what's ever in that text box right there, and we're trying to convert it into a decimal that's called hours worked. So literally the way that you read this is attempt to go in there, so attempt to parse that value. If it works, throw the output into the variable called hours worked. If it doesn't work, that's where we had that message box that said input must be numeric type of an idea. So it's, again, it's in some ways it's the old 6 of one, half dozen of the other. But what this does is it allows you to do the equivalent of exception handling without having to write try-catch statements. So it will run faster, and it is the recommended way to do this if you have a choice. All right. I would like you not in the example that we're doing, or the program assignment that you have for the converter, I'd like you to try using the Tryparse. All right. Now, if you say, Jeff, honest to goodness, I tried it and I couldn't get it to work, and I did the try-catch and it worked, okay. But I think you're gonna grow and expand your horizons as a programmer by doing it this way. This is the recommended way of doing it. All right. And notice we do the same thing then down below, but now it's the hourly rate. Again, attempt to parse that, to take that value that's in there and attempt to parse it, which means convert it into type decimal. If you can, put it into an output variable that's called hourly rate, and go on. So if I get down to right here, if I get down to line 101, this worked. Does that make sense to people? The only way I get inside of this if statement, so the only way I get in here is if that succeeded. If this fails, I go down to the else. So either the if succeeds here and I do all this, or the if fails and I do all this. Now that is something that's going to have to make sense to you as we go on, because you're going to be writing code like that in virtually every program that you do from now on. So again, in this case, attempt again to take the hourly rate, and if you can, then do your reasonableness checks. All right? If it's less than whatever we said the minimum was, and I don't remember what that is, or it's greater than whatever we said the maximum was, then it's an out-of-range error. So we're doing the same kind of stuff. If you literally printed this out, and you printed out the one that we did the other day, you'd notice that the only difference is that what we're doing in here, that was in the try, and what we're doing in here, that was in the catch. But other than that, it's basically the same code. But again, because of the fact that it doesn't use exception handlers, it should run faster. And it's the recommended way of doing things. Now, so why did I take the time to tell you that? Because if you look in the chapter here, they talk a little bit about an if statement and what it is. You know, he always does stuff like this, because you and I don't talk like this. Gee, if it's cold outside, I'll wear a coat. Else, I won't wear a coat. But what they're saying is, remember, the computer is a literal animal that has the mental capacity of about an 18-month-old child. So you've got to be very literal with it. So he explains all that stuff first, talks about, you know, when you have an if, it's got to be within parentheses. That's a Boolean expression. If there's more than one statement, it has to be inside of curly braces. If there's only one, you don't have to make it inside of curly braces, although you can and typically should. Then he goes in and he talks to you about the relational operators here, as you can see on the top of page 200. The key one, or key ones to realize, are these bottom two. Most people are pretty comfortable with greater than, less than, greater than or equal to, less than or equal to. These two must be put in this order. You can't say equal greater than or equal less than. It won't work. Notice for equality, it's a double equals. Double equals means equality. Single equals means assignment. All right? And not equal to, that's the exclamation mark, equal sign. Sometimes it's called ball bat equals. Sometimes it's called bang equals. Depends. Usually in the Unix or Starnix environment, it'll be called bang. All right? So they give you some examples of that, of each one of these. And then they give you an example program that basically says if your sales were greater than $50,000, then you are entitled to a bonus of $500. Now think about for a second what that means. That means that your sales has to be $50,000.01 or more. So if your sales are exactly $50,000, you won't get a bonus. All right? And that's the way you have to start thinking about things. Okay? And they show you this example here, and they write a program. And what they do here, this is a simple test program where you put in 3 test scores, it adds the 3 up, and it gives you an average. All right? So why did we do that? That's something we've done a lot earlier. Yes, it is. But if you look at it again, he started here with the old try-catch. And he made sure you put something in each one of those. I don't like this because when he uses catch, he just says exception. That's called a generic exception handler. If you remember what we did, we used a named exception handler. We used format exception right there. If you know the type of exception that's going to be thrown, you should always put it in. All right? And you can have more than one catch statement. We won't talk about that in here, but we will in Java. Then they say not only can you have an if, but you can have an else. All right, and they show the way that that's set up. And then, does this look familiar to you? I wrote my own. This is not the one that's in the book, so it's not done exactly the same way, but it's similar. And you see the logic that he uses here. Again, he uses try-catch, but the logic is very similar to the one we went over in class. Okay? Then he talks about nested decision structures. And guess what? The good news is you've already seen one. That's a nested if. The second if is inside of the first if. All right? So again, what that means is this has to be true before you do this. All right? And again, we've talked about stuff like this. We've looked at a couple examples like this, and there are several examples that are like this in the book. All right? And with the example that he gives for a program is he says, okay, if your salary is over $40,000, then you can check and see if you've been on the job for 2 years. So if that's true, if that if statement is true, you do another if statement. If both if statements are true, you qualify for a loan. If the first one's true and the second one's false, you don't qualify for a loan. If the first one's false, you just don't qualify right away. And he gives you that in this loan qualifier application. And again, the only reason I'm showing you that is, again, what you'll see when you look is there's an if that's within an if. All right, so that's the nested if type of structures. He mentions that when you do this, you can write stuff like this. That's totally legit to write it like that, but it really looks ugly. You may or may not have noticed that the way I wrote mine, and I didn't write this anyplace special, Visual Studio automatically sets tabs up for you. If you don't like what the tabs are set for, and I think it's like 4 spaces, you can go in through the options and you can change them. Some people only like them to be about 2 spaces or so. All right. Then he goes and he does this type of test for a grade. Now, there's nothing at all wrong with what he does here, except he writes it, and this is very hard to read. Okay? Also, when I test for grades, I like to think optimistically, so I start with the A's and work my way down. He's starting with the F's and working his way up. All right? So normally you'll see stuff written like this, where it'll be tabbed over, set up like this, looking nicer like this, a little more symmetrical in nature, so like this. All right? And again, that's what you naturally get anyway from Visual Studio. Okay? Not only do you have these relational operators, you've got logical operators. And to just quickly show you those, if I come through here and do this, int x equal 3, int y equals 7, and I'm going to say right now, int z equals 0. I'm making all this up. It doesn't mean anything. And if I say if x greater than 3 and y greater than or equal to 2, then I want to do something. I don't care what it is. So I'll just put a comment in here that says do something. Am I going to get into this? Do I get into that body? I'm asking you. Yes or no, and why or why not? I heard no. Why not? No, y is greater than or equal to 2, but x is not greater than 3. Right? So with an and, both halves of the equation here, this has to be true and that has to be true. On the other hand, if I did this, that's or. Then only one of them has to be true. And as soon as it says, oh, no, that isn't true, so it checks this one. just so you know, what happens in this language, and it also happens in Visual Basic.net, and it also happens in Java, is by default, this does what's called short circuit evaluation. In other words, if I do this, would you agree that x is greater than 2? Since this is an OR, I don't have to check this one, right? Because only one of them has to be true. So the way that it works here is if it finds the first one is true with an OR, it doesn't check the second one. You can force that to happen, but I'm not going to go into it right now by doing that. All right. On the other hand, if I do this, all right, if I do an and if this hits back to where we had it before, as soon as it finds that one is false, it doesn't check this one because it doesn't have to. It doesn't do any more work, the system, than it has to do. Now, if you've never seen this stuff, chances are you have not taken the logic class, or whatever the heck it's called now, math and logic, or whatever it is. Julie Bellman has taught it for years. I know there's another gentleman that they hired here. He's been teaching it also. But that's one of the things that's recommended in the first semester, so you get this logic. All right? And if you think this isn't used, when I went on for my master's degree, I took a couple computer architecture classes. And literally what they did, if you remember these, well, none of you are probably old enough to remember these, but they literally gave us Heath kits. And we had to go in we had to go in and literally wire up AND gates and OR gates. And you knew it worked because you had a probe, and if you stuck the probe on there and it was correct, it would light up or not light up. That was the good news. The bad news is I had to do that at home, take it in my car, drive 35 miles from my house down to Chicago to show my instructor, hope I didn't hit a bump on the way, all right, because that could have totally screwed it all up. So I'd get there and I'd go into this little lab that they had, make sure it worked, and then take it in by the instructor. Because when I worked for my master's, I did it all basically online. But for that kind of class, I had to take it in. Okay? And you really learn what that stuff is like when you see the wiring. Because again, remember, when it all boils down to is the computer knows zeros and ones. True, false, yes, no, whatever you want to call it. All right? The other one that's in here is not. All right? Not married is single. Not a union member means you're not a union member. So it's the not, the exclamation point, is also called an inverter because it changes the value. Not true means false. Not false means true. Okay? So what some people like to do, and again, everyone's different. If I wanted to just, let's forget about all this stuff that we put in here. All right? If you wanted to say if x is greater than or equal to 3, I want to say if x is greater than 3, I could also say if not, what, x less than or equal to 3 type of an idea. All right? And you can almost always go and write something like this. All right? Now, when I learned this stuff, the instructor would show this and then say, yeah, but if you write like that, you're wired a little bit differently. And you're not normal, which everybody thinks differently. If that makes more sense to you to do it that way, then that's the way that you should do it. That's the way that I look at it. And I didn't think that guy was wired right anyway. All right, so he talks about the and he shows you the truth table, talks about the or and the truth table, and he also talks about short circuit, which I just mentioned. Then he gives the not and the truth table again. Then he talks about precedence. And what precedence means is if I've got some butt-ugly statement that says something like this. If x is greater than 3 and y is less than 2 or not z, something like that. So if I've got ands and I've got ors and I've got nots, even without that, all right, so I'm going to remove all these, which you shouldn't do, but I'm going to anyway. And just put 1 around the whole thing here, like this. All right? The precedence is you do your nots first, then you do your ands, and then you do your ors. And when you think about it, that should make sense to you. Because not is the most restrictive. That's changing something permanently. All right? Then and is the next most restrictive, because they both have to be true, or the whole thing's false. and or is the least restrictive. All right, and if you want to change that order of precedence, you have to use parentheses. We've talked about this before. All right. He talks about Boolean flags. I just want to make sure that you see this. Okay, if I come in here and literally create myself a Boolean variable, so I'm going to come in here and do this. I'm going to say bool, and I'll just call it married, and set that equal to true. All right, and then where I've got dot, 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 there's some code in there. I don't care what it is, except that it's possible that somewhere in there I change the value of married. Okay, it's possible that somewhere in there. What I want to show you is this. If I type in this, those do the same thing. The second one is a shortcut for the first, and it works like that in virtually every programming language that I know. You'll never see a professional programmer write like this because very few of them like to type. So you'll just write it like that. All right, and in much the same way, these two are the same here. All right. Now, if you say, well, I'm just learning this stuff and it makes more sense for me to write, then write it that way. All right. But I will tell you, in a professional working environment, you won't write it that way. All right. When you compare strings, you can do this. Might not look like a big thing, but you can do it. So I can do that. Set up a string, name 1 equals Mary, name 2 equal Mark. And when you think about it, what the system does when you do this, it makes what's called, real fancy term, a lexicographical comparison. So it says, they're the same, they're the same, they're the same, they're different. So it compares letter by letter. What if I had put in here, instead of Mark, what if I had put in Mar? So it looked like this. The first thing the system will automatically do is it'll put a space in there because it wants what it compares to be the same size. Now, if I come through here and I compare Mary with Jeff, it fails on the first character. So it knows that it's done. They're not the same. Okay? So you can take strings like this and do it this way. Now, this won't mean much for some of you in here, but I just want to show you this. Because if you're doing the same thing, as an example, if you're doing the same exact thing in Java, you can't do it like this. You've literally then got to say if name1 dot equals, you've got to do it like that. And the only reason I'm showing you that is C# is kind of an offshoot of VB.NET and Java. So it took some of the stuff, because that's the way you do it in VB.NET. All right? But you can't do it that way. If you try doing this, if I try doing this in Java, even if I have these, that right there, that'll fail in Java. Because it's comparing things differently in Java than it does in C#. All right? But we're not in Java, so I just thought I'd show you that. So. Then they talk about this lexicographical comparison. That's all fine and dandy. Then finally, they get to what I just showed you. Preventing data conversion exceptions with the Tryparse. And again, the author says here, exceptions should be prevented when possible. Well, that's fine, but he really doesn't say why. All right? And if you're an inquisitive type, all right, for example, my middle daughter, you know, when she was little, she always wanted to touch the hot stove. You know, and I'd always say, no, 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 don't do that, Mackenzie. So one day, I guess I wasn't around, or I didn't say it fast enough, and she touched it. She burned her fingers pretty badly for a little kid, and she didn't do it again. All right? But maybe that's what she needed. She needed it to be proven to her, because I don't remember her ever doing it again afterward. All right? So again, in the stuff that I gave you, I already talked about this one. And I also went out to a site that looks a little goofy when you see that thing up there. All right? But it's called coderanch.com, and somebody asked, "Hi everyone, why should exception handling techniques not be used?" And the person who answered, "This is pretty good because it's simple," but he gives two reasons. He says, number one, basically what you're doing is the equivalent of a goto, and gotos really aren't allowed in conventional programming languages. And the other one is what I mentioned. Creating and catching an exceptions brings overhead of creating a brand new object which slows the program down and makes it run a little bit worse, so to speak, than doing it the other way. All right? So he goes through here and he does his own tryparse. I didn't like his example, which says try to do it, and if it works, say success, and otherwise say it's not a valid integer. There's nothing wrong with it, I just didn't like his example. All right? So then he told you to enter two integers. All right? And he said integers only, please, and he did the same kind of thing. I didn't like that example either. So what I did was that's when I went back and rewrote my own example, the one that you've already looked at, all right, this employee example. So you've got an example of that. So again, I'm saying it again, what I want you to do is on your assignment, which we'll go over by the end of class, I want to make sure for the distance converter, you attempt to use either decimal tryparse or int.tryparse or double.tryparse. Are there any questions on that? So, hey, look familiar? How about a miles per gallon program? All right. Again, I didn't take his. I always write my own stuff. But his is out there if you want to take a look at it. Remember, every single one of these programs that's here, that we're looking at in your textbook, if you do, as always, go out to the P drive for the class, there is a folder out there called source code. It's all out there for the entire book. So if you're struggling with anything, I'd highly encourage you, use me, use the lab assistants, yes. But if you're at home and you're working on it, all right, you're having problems, go take a look at a program that might look at least somewhat similar because you've got it. All right, remember, if you want a program, so if I want that program, the fuel economy with Tryparse, I can't run it from here. I've got to right mouse click on it, drag down here and choose copy. And copy it to my desktop. Then I can do whatever I want to do with it. But you don't have the ability to write and to run programs from the P drive. To my knowledge, at least, you don't. All right. So again, he goes through that, and he's got a lot of, an example here with the miles per gallon, and he basically goes back with that one and does it with a tryparse. All right. So again, if you have problems on the homework using Tryparse, I'd suggest you look at this program that starts on around page 238. All right. The next thing he talks about in here is input validation. Guess what? You've been doing that. All right. And input validation basically falls into two types. You've already been doing both types. The first is when you're expecting a number, you check to make sure if they put in something non-numeric or left it blank, you handle it. The second one are reasonableness checks, and you've done those too. All right, again, it really wouldn't have probably made a lot of sense in that payroll program to allow, somebody makes $1 million an hour. All right. Is it possible that somebody does? Maybe it is. No one I know of. All right. So he talks a little bit about input validation. Again, that's the reasonableness checks. Now he says, for example, if you're doing the hours per week, that's a range check, right? Hours have to be greater than 0 and less than or equal to 168, but that's not reasonable. All right, I know a lot of us think, well, I do work 24 hours a day, but you don't. All right, and most people who say they do don't work 12 hours a day. But let's assume then that we change this to greater than 0 and less than or equal to 84. That would then be a reasonableness check. So he talks about that in here. All right. And next he goes into radio buttons, checkboxes, and buttons. What I'm going to do is for the next about 10 minutes, so if somebody can tell me when it's 8:45, we're going to break a little early today. Tell me when it's 8:45. We're going to take a break, so I'll talk about this until then. After that, I'm going to stop this run. I don't need that program anymore. But we're going to look at the other one because I wrote a demo program in here also. And that demo program, as you'll see when I run it in just a second, I tried to incorporate a lot of the stuff that he had in the chapter. All right. So when you run this, you have the three types of controls that are discussed in the rest of the chapter here. The first are radio buttons. Notice with the radio button, they're meant to simulate the old radio buttons from AM radios in a car. Only one can be selected at a time. So if I choose football, it says your favorite sport is football. All right. If I don't choose anything, it says you didn't choose anything. So we're going to look at that. Then you have checkboxes, and you all have seen this before. You know, it used to be with like bold, italicized, and underlined, they would have checkboxes by them. So I can choose one, or I can choose more than one. And I just kept it where it showed them both like this. All right. And this is a list box where I can choose my favorite day of the week and have it show. And I've also set it up so that when you do this, you can clear radio buttons, clear checkboxes, and clear the list box. And that's the program. So we're going to go over that program after the break. So what I'd like to do before the break is talk about the rest of the junk, which is kind of what it is, that's in the rest of the chapter here, starting on page 241. And it goes for somewhere around 10 to 15 pages. But a lot of it are just pictures and code snippets and whatever. So what you see here, those are radio buttons. You may or may not have noticed it, but if you look up on the screen, look at their radio buttons and look at mine. They look different because I put mine in what's called a group box control. You should get used to when you've got controls that are going to be common and they're doing something as a group to actually use a group box control. All right, we'll talk about that after the break. To me, it just makes it a little bit easier to work with, and you can see I changed the background color so it would stand out. All right. But again, radio buttons are for mutually exclusive choices. So if this was your favorite drink, you'd have to choose one of those, but you couldn't choose more than one. All right, as it says, it's called a mutually exclusive selection. All right, so here's a couple different ones, and again, those have both been put into different group boxes. All right, now notice that there are different properties that we have for this. There's a text property. All right, and I'm going to, maybe I shouldn't do it this way, but I'm going to do it anyway. That if I come out here and try to start up a new Visual Studio, and I'm just going to bring up a new project, I'm just going to create a garbage project right before your very eyes. It's so important that I'm going to call it Windows Form Application 1. But if I come through there, all right, and I come through and I drag out a couple of these radio buttons. So a radio button, a radio button, a radio button. All right, and I run the program. You'll notice only one of them can be checked. The system's smart enough to know that. But again, you typically group them together anyway, and there's a reason that we'll get into after the break for doing that. All right, so I come back here. And the weird thing is, the way that you do this, it's very hard for you to go in after the fact and find the group box control, which is right there, drag it in here, and then grab these and drag them into here. It doesn't usually work very well to do it that way. All right. In other words, what you should do is you should make the group box first, then go in and drag your controls in there one at a time. Does that make sense? All right. That's the recommended way of doing it. All right. And notice, I don't even know what I put there. Let me try to run it again. Notice, since it's in the group box, the system realizes it's not part of the other ones. So I can't have any of those checked, but I can also have this one checked. All right. So again, we'll look at that after the break. So he talks about, that's the property you use. It's a Boolean property. Remember, Boolean means true, false. So if it's set to checked, then the little black dot is on there. If checked is set to true. You can check for it like this. That's what I did. Okay, I basically did that one. I didn't like the way he wrote it, so I rewrote it. Checkboxes are very similar to radio buttons, except they're not mutually exclusive. but they work the same in that they've got a checked property, all right, and they've got a text property. Okay, so if I come back to that program again, I'm just going to remove these. I'm going to come back in because I like to do it this way, and start by bringing in fact, I won't even do it. I'll just bring in some checkboxes. I'll just throw them in there. Where he says right here with his checkbox, where he talks about the text property, that's the thing that says checkbox 1, checkbox 2, and checkbox 3. All right? So if I wrote in here, for example, if I clicked in here and I went to text, if I run the program, this is not an example where you would use checkboxes. There should have been radio buttons, because it is possible, because I implemented this like this, that somebody could put down they were a female, a male, and unknown. So you wouldn't want to do it like that. You would instead want to use checkboxes. All right? But they are very similar. The main difference between them is that these are non-mutually exclusive, where checkboxes are mutually exclusive. All right, so let's take a break. It's about 8:45. We'll pick it up on page 245 here. We just have 5 or so pages to go. Let's come back at 9 o'clock, please.